Hi everyone. Again, thank you very much for joining this webinar. So I think we are all ready to start. So everyone that enters after, they can ask questions. So we will start right away our webinar. So first of all, let me just say, if you have any questions, you have the place where you can ask your questions, and then at the end, I will read all the questions and, of course, give all the proper answers. If for some reason we run out of the time, we will personally contact you by email to schedule a follow-up and to answer all your questions and any other question that you might have. So again, thank you very much for joining. This webinar is basically to show you all the or some of the capabilities of the tool called Alteryx. So before we actually start, so who are the presenters? So my name is Gonçalo Pereira. I'm the technical lead for Climber in the UK office. I'm here with my colleague and senior consultant, Kishan. He will also be one of the presenters. So let's speak a little bit about history, about Climber. So very quickly, we are partners, Alteryx partners and Qlik Elite partner. We have several offices across Europe. We are more or less around 80 people, and everyone combined, we have more than 100 certifications, Qlik and Alteryx. And basically, we have several customers, not only in our geographic, but we also in other countries, like Germany, like US. So we actually have several knowledge and experience delivering several tools and several BI applications. Just to give you just an idea of what we actually do. So we have our services, basically BI applications, advisory. We also have what we call expert service, that is everything around infrastructure. So if you want to host a server or a Qlik or an Alteryx environment, we can actually give that support to you. And also training users or also developers, we can actually help you providing the right solution or the right training. So these are some examples of our customers. So we actually do work for Travelport, PwC, Santander or Belmont. So we actually have experience delivering work in QlikSense, QlikView, and also Alteryx. So we actually have that experience. So now let's start the actually webinar, the agenda for today. So the first topic, I will do a very quick presentation. So just some slides, and then the idea is basically just showing you the actually what Alteryx can do, and then show you the actual results. So the first thing I will tell you what tools we actually use to prepare this webinar, the data, where we actually got the data, then what is Alteryx, what makes Alteryx different, and also what you will see during this webinar. So about the tools. So we are going to use and show you Alteryx and QlikSense. So Alteryx is going to be our main tool. So to show you data extraction, how to prepare the data or do advanced analytics. And then QlikSense is going to be purely a data visualization tool. So everything is only about the Alteryx, and then the visualization is Sense. Regarding the data, so we have here it's all open source, so the data is available on these links like the data.police.uk. So is where we got all the, sorry, is where we actually got all the data about the crimes. Um, and then we have all the other data like demographic and also the local authority and index of deprivation. So this is all open source. This is all official, um, official, official, official data from the government. So it's all available to use. So you can go to these links and just do the download. So what is Alteryx? So very generic overview. Alteryx is basically a tool that you can use to prepare data, to extract data, to analyze the data that you have, and also to create more advanced analytics. So in this case, we are talking about, for instance, predictive analytics or geo analytics. So, and the best thing of Alteryx, it's more, and it's actually what makes it different, is you don't need to know how to code. So Alteryx is all based in the technology drag and drop. So you only select the tool you want to use, and you just then click run, and Alteryx does all the code or all the preparation that he needs. Alteryx is basically a tool where you create your own workflow. So it's very intuitive. It's able to actually to work with lots of data in a quick way. So because Alteryx is prepared to actually to run the data, and then of course produce advanced analytics like predictive, like the time series, like cluster analysis, all those type of advanced analytics that we actually can perform here. One other thing about Alteryx is, so Alteryx is not dependent of any other tool. So let's say you are using this tool in your organization. For some reason, you have, let's say, tool A as your main visualization tool. If tomorrow your organization decides to move to another visualization tool, it doesn't matter for Alteryx. So Alteryx will remain the same. All the workflows, all the work you already did, all the investment you already did will remain. You just need to change your visualization tool. So no dependence here. So it's basically an agnostic tool that does not require any dependency. Just to finish very quickly, so what we will show you during this demo is a very quick example how to perform a data extraction, how to perform very simple and to give you an idea of how you can actually transform or prepare the data. Then my colleague Kishan will explain you all the logic behind the time series analysis, so the forecasting, and also more advanced analysis, the cluster analysis. And then at the end, we are basically going to show you all the data visualization, all our results of all the work we did with Alteryx. So let's just start the actual demo. So first of all, this is the Alteryx designer. So this is the, let's say, the main tool that you can use. So we have here all the tabs, and each tab has several tools like the ones we are looking here. For instance, we have the in and out tools, the preparations, and then the joins, transforms. So different categories to do different actions. So in this case, we are going to simulate an extraction for the API. In this case, the API that is available on the crime, on the website or that we extracted the crime data. So very simple, what we have here at the moment is just the text, a text field, where we have basically the URL for our API. So, and now what we need to do actually is to ask Alteryx to download that information. So the only thing we go is to connectors, where we have all the different types of connectors and where we can actually connect to different types of data source. So drag and drop again the tool, and then he already identifies the field. And for instance, we can go right click here and just say add browse. So this is the browse tool that will allow you to see the result. So and here click run. And now, as we can see, so this is the URL. So we made the request, and this is our download data. So in this case, just to show you, so this is the API response. So when we need to prepare this data to get actually the fields. Just to give you an example, I have here already a workflow that can actually translate this API. So just to show you very quickly, again, we have exactly the same thing, the same URL. We are downloading from the same place. And then what we actually have is basically several tools that will allow us to select which fields we want to see, and then to apply some different transformations. For instance, replace this icon for nothing. So basically to do small transformation that at the end, when we run, we will get basically our desired result. So basically what we did was we transformed this string in a table like this, in a table with all the fields we need. So this is actually our first step, just to understand. We in this case, we wanted to show you a little bit more than just extract from the normal Excel. So that's why we actually went to try to extract from the API instead of a normal Excel. The other thing I would like to show you also is just to show you how easy actually is to work with Alteryx. So in this case, let's try just to do some kind of transformation. So in and out tab to, in this case, to join, to add data to the Alteryx. So input data, then we have here where we actually select the field, the file, sorry. So I have here already data prepared, so select here. He opens, he gives us a preview of our data and all the fields we have. And now what we want is actually to start cleaning this data and basically to get our final result. So at the beginning, what we want to do is just remove all the crime IDs that are equal to null. So for instance, we can go to the preparation, we go to the filter, drag and drop. Now we just need to say what kind of filter we want to apply. Crime ID is not null. And then let's just add the browsers, run. So, and as we can see, now we have two different results. So we actually have one result that basically is excluding all the nulls. And then we have one result that is all the crime IDs that are equal to null. This is actually very important because this can actually, we can actually be looking to data that is actually important to analyze further. do further analyze to understand if it is actually data that we need to release, to drop, just forget, or to actually to fix and then include in our sample. So, and then, for instance, we can actually, let's say, just store this data to actually to a file so we can analyze later on to understand what is actually a problem. So, for instance, we add the name, we can select the type of field or the type of file, and then just click Save. Now, what we can actually do more. So, lots of things. Let's say create a new field. So, just drag and drop here at the column, for instance, crime, and number one, a counter. So, but instead of the data type string, we want a double. Okay, so this is the type of transformations we can actually do. Or for instance, just drag and drop this one, the select one. And for instance, we want to drop some fields because we actually don't need them. For instance, year, context, location, latitude, longitude, and I want to rename this field to LSOA. So if we click run, this is what we can actually do, and basically at the end to see all our data, and then of course prepare how we want, how we would like to see it, and then display in a different visualization tool or in a different tool. So this is actually to give you just an idea of what we can do. And I'm not going to bother you more with these data preps. So I will give the word to my colleague, Kishan, where he's going to actually to explain the good stuff, the predictive part. So how we can actually create a prediction to see the future, to see what's actually is going to happen. So just bear with me and wait just a moment, please, while I move the presentation to my colleague.
Thank you, Qlik. So just to continue from where we left off, I've got a data set here that contains the completely prepared and clean version of what Qlik was showing earlier. For the purposes of our demo, we are going to use a small subset of information, but you'll see at the end the total work that we've done so far inside QlikSense. So the data set that you can see here is the number of crimes in Brent from January 2012 all the way through to March 2018. What we're going to run in this first example is the time series element. There's two different versions, and I will go through them briefly, but the first thing we want to do is separate our data slightly. So we want to try and keep a couple of months separate, just so we can validate anything we forecast. We do that using a filter tool. And what we're going to do is we're going to remove all of the dates before 2018. And running this quickly, we can see how this is separated out. So we've got one stream of data that has all of the crimes in Brent from January 2012 all the way through to December 2017. And we have another stream of data that contains the number of crimes in Brent in January, February, and March 2018. Now, just before I run the time series, I should explain there's two different tools that Alteryx allows us to use, ARIMA and ETS, and I will explain them in a moment whilst we're running, but for the purposes of this demo, we're going to use the ARIMA tool. This actually models our crime forecast based on the data that we've seen just previously. And we can configure the tool to exactly what we want to find, so we can target the number of crimes as that is what we want to model. And we can select the filter frequency. So we know that our data is monthly, so we can configure it accordingly. We also know that our data starts in 2012. So we can add that in. And we want to plot the next 3 months so we can eventually compare and validate the data that we've got. And let's just select the UK format. I'm going to add a browse tool so we can see exactly how it looks when we run it. Here. The second stage of the time series is actually using a TS forecast tool. Now what this does is, instead of the ARIMA, which actually produces the model, the forecast tool will produce the forecast of the crime based on the model. There's a few selections we can make here. We can choose our confidence intervals, 95 and 80, which are kind of the traditional values that you use. And we can choose the number of periods that we want to forecast in the future. So in our case, we want to forecast 3 as we have removed the 2018 data to test against. So let's just put that to 3. And let's add a browse tool so we can see the output. And just give it a second. And let's run that. So while this is running, I should explain that Alteryx has 2 tools to formulate a time series, ARIMA and ETS. They both can be used very differently, and you can compare and pick and choose which one you want. ARIMA stands for an autoregressive integrated moving average. And as the name suggests, it utilizes the moving average for its forecasting within its data. But it also allows you to use a covariate. So that is an additional field which you can use as predictors for crime to increase the viability of your model. We can use ETS on the other hand. That estimates the time series by using a weighted average on past observations, giving more of a weight to more recent fields. So if we take a look at our ARIMA plot, we can see exactly what the model has produced. So you can see our crime figures in Brent from January 12 up until January 2018, and it just gives us a little indicator here of exactly how the model forecasts crime to go in the first 3 months of 2018. And the second browse tool actually just puts in the forecast figures just so we can see exactly how it fits. Now this is all well and good, but we would like to validate the information so we can see how closely our output here resembles the actual crime figures that we picked up here. So what we need to do is validate, and I've prepared a little script earlier, which we can use to compare against. I'm just going to pop these into a container, so we don't need to worry about running that again. So the way we compare the 2 sets of information, if we have a look at the input down below, we recognize here that this is the same as the output that we had previously from the time series. We need to join this data to this data, which we do using a key, and then using the join tool. We then calculate the percentage difference between them and sort it, so we're able to get a final figure for the percentage difference according to the actual number of crimes against its forecast. So we can actually see that for the 3 months we have in Brent, for January we're only 1.46% off, ranging all the way through to 4.71% in March. There are various reasons for this, which I won't go into, but you'll see later on how this is impacted across all areas in England. Now, for the second example, I'm going to talk through some predictive grouping. Using the crime data is all well and good, but to get some real insight into what we're trying to do, we need to enrich our data. The way we have decided to do that was to add supplementary information. The 2 things we went for were the English indices of deprivation, which are an overall measure of the deprivation, which are experienced by people living in LSOA areas or lower layer super alpha area, which is essentially grouping smaller regions of the English population in groups of 1,000, just to get a better idea of what's actually happening. And this is a new government terminology that they've been using over the last few years. We've also added in some population data as well, so we can see the proportion of male and female within the age groups as well. You can see the first few fields here after crimes are some of the measures of the deprivation index, and I will explain the more relevant ones a bit later on. So the first thing we want to do is, since we're using predictive grouping, the idea is to get all of the different areas sorted into various clusters. So we can try and figure out whether there is any kind of link between all of those areas and crime. In order to do that, within Alteryx, we can use an association analysis tool. What this allows us to do is it allows us to determine the various fields or variables and how they have a relationship with one another. So for instance, we want to target crimes because that's what we're interested in. We then select all of the various variables that we want to measure it against. And looking at the output, so we can see how correlated each of those measures are to crime. It's only the first two columns here that are most relevant. We can ignore everything else for now, as we're interested in the impact on crime. Now, a score of 1 represents a full positive correlation, so you can expect crimes and crimes to have a full positive correlation. And -1 represents a full negative correlation. Whoever is creating the model needs to decide what their baseline should be. For our case, we want to use 0.5. So anything over 0.5 suggests to us that there is a good positive correlation for each of these factors here, where I'm hovering over my mouse, to crime. So let's just make a note of these. So we've got the average income score rate. So this is from the deprivation index. It measures the proportion of the population who are in an area that has low income. Low income is defined by the number of people who are out of work, and also those that are working who don't earn enough to qualify for base level tax. And this is a loose definition that we're using for now, but that's the basis of it. The next one, if we look down, is the average income deprivation affecting children index. This is a proportion of all children aged 0 to 15 living in income-deprived families, which is defined as a family that is receiving some kind of income support. If we drop down, we've also got outdoor subdomain, again from the deprivation index. This is actually a measure of the local environment through measures of air quality and road traffic accidents involving some kind of injury to either a pedestrian or a cyclist. The only other two that are over 0.5 are the percentage of female 18 to 35 and percentage of male 18 to 35. What's interesting about this is you'll note that the income score and income deprivation affect children. Yeah, that would be logical as to why it affects crime. But something like outdoors is not something that one would assume is related to crime. However, using Alteryx, we are able to pick up a variable that actually seems to have a positive correlation to the number of crimes in an area, which we can use to model further on. So the next step along this clustering journey is to actually figure out what the cluster should be. We use k-centroids to do our predictive grouping, and essentially what these are they're basically a class of algorithms where you can partition or divide all of the different areas into a certain number of groups, which is what the k represents. It's k number of groups. I won't go into too much more detail about here, but Alteryx has a tool called k-centroids diagnostics, and this actually allows the user to create an assessment of the appropriate number of clusters that you'd want to be able to use. To configure it, you select the fields that we actually figured out from our association analysis tool, the fields that we think have the biggest impact on crime. So obviously crime is not relevant, as we know that's what we're testing against, but we include the other 5 factors, as you can see there. We standardize the fields across and we choose a clustering method. Again, I won't go into too much detail about these for the demo, but you can actually select a minimum and maximum number of clusters that you want to test against. This is actually a very computer-intensive, power-intensive function. So the more clusters you put in, the longer it will take. We've actually run this earlier, and we can see from the output that. And we can see from the output here how we can decide what our appropriate number of clusters could be. Without, again, going into too much detail for the demo, ideally you want both of these indices here to have the highest mean for a particular cluster. So just doing like a quick baseline look across, we can see that 2 and 4 have the higher means here, but 4 at the bottom here is a lot higher. So 4 is probably the right way to go in this case. There is no perfect answer to this question. It's more a case of what you want to model for. Very often you will find that 2 actually has the highest means for both, but it doesn't necessarily add anything to the data you're trying to produce, and you may want to use more as a result. So the final step is, now we determined that 4 is the number of clusters to use, we actually need to run the k-centroid cluster analysis tool. You'll notice that the configuration is essentially exactly the same as the diagnostics tool, except instead of choosing a minimum maximum, you choose the actual number of clusters that you want to use. You then use the append cluster tool. So after the previous tool calculates what it assumes the clusters to be in through its algorithm, you're actually able to append each cluster group, if you can see on the right here, to your original data, which you can then use for further analysis. Now, I've actually grouped the data just to have a look and see how many areas come into which cluster for our demo. And we can see that there are 4 different clusters of varying areas. So cluster 4 is a lot bigger than cluster 3, and it's done this according to its algorithm. So this is the end of the base example, but in a second, I'm just going to hand over to Gonzalo, who is going to show you the work that we've been doing, which involves the use of all crime data across all areas and regions in England, and our forecasted model for it.
Okay, thank you very much, Kishan. It was actually very helpful to understand what we actually are going to change to show now. So just a very quick note. So at the moment, what we are actually seeing is basically our sample. So what we did was to get the data since 2012 until the end of 2017. So we have all that data in terms of the crimes. So this is actually our sample. This is actually the data we use to predict the next 3 years. So what we are actually doing is our prediction for the full year of 2018 until the end of 2020. So based on all these numbers. So in terms of a very quick explanation in terms of the Qlik sense. So we have here all the data, the number of crimes we have, the several regions and areas. So we can actually start filtering, and we actually see all the trends we have across, in this case, across this region, and the numbers in terms of the highest crime area, and the lowest year in terms of crime, and the highest crime. So again, very simple explanation. This is actually our sample, and the part that actually is very interesting is the next one. So this is our presentation in terms of our results. So what we are actually showing here is the 3 years that we actually predict. So based on the previous data, so again, from 2012 until the end of 2017, we are predicting the data or the crimes since the beginning of 2018 until the end of 2020. So a very quick story in terms of the numbers. During these 3 years, we will have around 13 million offense. So this can actually be non-violent crimes or violent crimes. So it's all included. So we can also see the comparison between the last 3 years, so since 2015 until 2017, compare with the 3 years we are predicting. We predict that we have an increase of 20% of the number of offense crimes. And then again, we can actually see the trend in terms of how the the crimes will, let's say, evolve across the time. One of the things we would also like to show you in terms of our prediction is something that is actually very interesting, is the seasonality of the crimes. So the blue line is actually our historical data since 2012 until the end of 2017. And we can actually see our predictions in terms of the seasonality. Basically, they are a match. So we can actually see that we have, let's say, a logic in terms of the seasonality from what is actually happening and what we actually build in our model to predict the future. So now one of the things I actually want to show, because it's very interesting in terms of the numbers. So why have we decided to have the sample between 2012 and until the end of 2017? So we made this decision to, because we can actually tell it, we can predict the future. But the best way to show you is to actually compare our predictions against the reality. So that is what we can actually see here, where we see a darker blue. So what we actually have here, if we overlap our mouse, is our historical data. So the real data that you can actually download from that website, and what we actually predict. So in terms of reality, we are talking about 366,000 crimes, and what we predict is 355 crimes. So we are talking about a difference of around 3%. So it's actually very impressive in terms of, if we start to drill down a little bit more, that I will show you, it's actually very impressive to see that our predictions are always around between 1 and 5% difference. And for instance, just to show you again, we have the February is actually our highest difference, that we are talking about 4 or 5%. And then we actually have March, that is actually our lowest difference, that is basically between 1 and 1.5% difference. So the other thing is, when we are making a prediction, we need to be careful in terms of what kind of details we want to use. Because usually when we start to drill down, we start to lose the consistency. So, but in this case, we were actually able to start drilling down our predictions to the region, to the areas, and to the crime types. For instance, just to give you an example, if we select here Southwest, we can actually see, if we go here, so our historical data or our reality against our forecast is actually only a difference of 3 crimes. We actually predict 3 crimes more than actually happen. And then if we go again to February, we actually have a difference of almost 1,900 crimes. And again, the other one is very, very similar. So we can actually say, despite the fact we went to a different level of detail, for instance, again, if we drill down again for the non-violent crime, we can actually see what we have in reality and what we are actually predicting. So very similar. So we can actually say, in terms of, if we have good enough data, in terms of if it's stable, if we don't have loopholes or problems with the data, we can actually say Alteryx and the algorithms that Alteryx offers to us, we can actually say with confidence that we can fairly predict something that can actually help your organization for the future. And again, how we can do something like this, or how we can actually, let's say we are talking about crimes, but how can we actually implement this in the real world, in the organization role? So we can actually use this, for instance, to predict our sales, to predict in terms of the sales, and also our retail, our stock in terms of the number of products we have in the warehouse, something like that. So it was actually, to be honest, it was actually very impressive, the results we saw, because we just started to use this data. So we basically clean all the data. We read all the website to understand how the data works. And basically, after we prepare the data, we start working with the data, and we actually got very interesting results. But now, I would like to show you, besides the time series, also the cluster analysis that Kishan was talking about. And in here we have the average income score and the income deprivation affecting children index. So what we actually can see is, so the higher the score, the worst is, let's say, your area is. And the size of the bubbles is actually the crime ratio. So it's the crime against, is the population against the crime. So, and we can actually start to see, when we start going to more deprived areas, we can actually see that we have higher rate of crime. For instance, if we go here, we can actually see that one crime happens for every 3 people. And if we go here, and yes, and one crime happens here against for every 8 people, 8 person. So we can actually see the relationship. But what is actually important here is also to see the ones that actually get out of this context. For instance, if we start to drill down, we actually start to look areas like Westminster. For instance, it's basically one-to-one rate crime. So, but why? Probably here we can explain that is probably because of the highest tourist area. So this is the kind of analysis you can actually make, and especially if you utilize this option against your customers. For instance, let's say in an organization role, you would see this analysis like creating like a profile of your customers, where you would see your, let's say, customers that are actually performing well, and then you will see your customers that are underperforming, and then you will start to ask why these customers are completely different from these ones. Now perhaps I need to start seeing what makes them different and start to apply the same process and the same answers to those customers again also. So this is the type of questions we actually get from this analysis, and that's it. Basically, it's how we can analyze the clusters, and also how we can actually analyze and see the benefits from the time series forecasting. Before we go to the questions, I would like to ask my colleague Kishan if he has anything to add.
Yeah, so actually, it's actually relevant to one of the questions that we've had received throughout. And just put a quick reminder, if anybody does want to ask a question, just post it in the little pop-up that you've got there. So somebody actually asked how easily Alteryx can handle different data sources. Something I should note about all of the data that you've seen so far, it's actually all from public data sources, from various different places, as you saw before. So we've got some crime data from the police, we've got some data from ONS, we've got some other KML data from the map surveyors. But we can also, if we wanted to, include other data sets. So we could hook this up to some further, we can hook this up to some work information so we can see the number of companies in certain areas, or we can base it around the number of registered charities in a certain area. The idea is we can pull in a lot of information from a lot of different data sources. Alteryx also enables you to hook up to many different connectors as well. So whether you have like an Oracle-based platform or you're just using CSVs and so on and so forth, you can very easily actually just combine all the information in a similar way to how we joined the two streams earlier.
Oh, okay. So I don't know if anyone has any other questions. But let me just see. Please, you have an option where you can actually type your question, and we will see it. So let's. Okay, yeah. We have here another question. Is the question we have here is basically what kind of skills do we actually need to use Alteryx? So at the end, Alteryx, just to try to explain, Alteryx is what they call a self-service tool. So the main idea of Alteryx is actually to a business user and a normal analyst can actually come to the designer and basically just drag and drop and make their own analysis. So the thing is, you actually don't need how to code in R or in Python. You have all the options available that you actually need, for instance, to the time series or to use predictive models. So the only thing you need to know is to drag and drop your option. For instance, drag and drop the option you want to use, and all the code is behind of this tool. So basically, Alteryx creates all the code, and you can basically use that code in your advance for your advance. So no, you don't need to know how to code, and you don't need special skills to actually use Alteryx. You just need to have data, and you just need to have, let's say, the idea of what you want to achieve, and you basically have the tools to prepare the data and to work with your data. And that's it. Let me see if we have one more question.
Yeah, so we've had a question come through, just asking about where else we can apply these different prediction models. And actually, you can apply these models in pretty much any area, to be honest. You can apply it through sales forecasting. If you wanted to forecast some of the sales that you had, you can apply it through workforce planning, even forecasting stock and inventory. It all kind of depends on the kind of data you have. You don't necessarily need to worry about data quality so much either. Alteryx will allow you to actually clean and prepare your data in a way that it's actually usable. Beyond that, the applications are full and many. And I think unless anyone has any more questions, I think that might be enough to close off the webinar. So I'll hand back over to Gonzalo.
Yes, we actually have one more question that is about the existing package of SSIS. So if I'm understanding correctly, your question is basically if you can actually download and to extract correctly the data from the SSIS package. So the thing is, you can actually easily connect with several. Let me just ask, Kishan, can you please give me the presenter mode? Sorry. Yeah. So again, if I'm understanding correctly your question, yes, you can easily connect with different data source. So if we actually have an option that has several connectors, you Alteryx can actually give you option to build your own connector. You will have more connections also available in the community. So someone actually creates the connector and you can actually use it for free. But again, we also have all the standards connections. So if we go to the input and then we have all the usual database connections. So we basically to extract the data from several different places. So I would say my answer to your question is yes, definitely you can extract the data from those SSIS packets. So let me just go. Just again before we finish, I don't know if we have any other question. Nevertheless, if you need or if you have any other question, any other doubt about the what we actually did in terms of the work we did, our logic, please feel free to send the email to me or to Kishan, and we will answer all your questions, and we also will create another session to explain a little bit more deeper our logic. Nevertheless, I would like to also to say in the next couple of weeks, we will release in our website our logic in a more detailed level of what we actually did with the data and how we actually use Alteryx to prepare, to transform, and to do advanced analytics with this data. So it is actually something you can actually see and follow up and actually understand in more detail what we actually did. So we can actually, and also it's actually easier when we release this article in our website. We will definitely send you an email so you can actually see and basically read and then ask questions if you have. So if anyone has any questions, it's time to ask. If not, I would say thank you very much for coming. It was actually really fun doing this and to actually to learn and to see how Alteryx can actually help us to see the future and to try to do something different. So again, thank you very much for coming. Look forward to hear from you again in the next webinars or with some questions. So thank you very much and have a nice day.